Hello, and back again with me, Hendra. And this time I will make another comparison between Arduino and Micropython. This is the part 2 of my Arduino versus Micropython videos, as I made a previous video before this. And as I explained before, this is not, this is just a comparison. This is not comparing which one is better, which one is better platform or a better framework. Is Arduino better or Micropython better? No, this is not a video about that. This is just a comparison on how you can code with both of these platforms. Okay, so as you can see in here, I have two Wemos D1 Mini. In this side, this already has Micropython in it, and in this side, it has Arduino in it, Arduino firmware running. So now I'm going to compare. The first thing is the syntax. Okay, as you can see, this is the very basic syntax, the blink one. Too many comments in Arduino. It's actually this much coding for Arduino, and this is for the Micropython. So first thing first, as you can see, the Arduino side, it has the syntax is actually a bit look like C language, but actually it's not a C language. It's a heavily modified C, so it's another higher level of C, so everybody can code microcontroller directly and fast and doing a fast prototyping. But the problem is, there are two functions that has to be exist in Arduino, which is the setup function and the loop function. Without one of these, the Arduino will not run. So even though if you don't want any kind of loops, you don't want to use the loop, it still has to call the loop function and fill it with blanks like this. Vice versa. Also, if you don't want to use the setup function, you cannot erase the full setup function. You just can erase the content of the setup function like that. And also, as you can see, for calling an object, a pin object, which is very simple, which is we call it with pin mode. In this case, it's LED built-in, which is onboard LED in here, which is D4. Connected to the pin D4 in the Wemos D1 Mini. And after that, you call it, you want to make this pin as an input or an output. Just like this. And the most thing that C programmer or JavaScript programmer is the always forgetting is the semicolon, including me. I'm not judging everyone here, including myself. I always forget to put the semicolon at the end of the line. So this is necessary because it runs on C, so you have to follow this syntax rules from C, which is you have to use semicolon, which is always be forgotten. Always be forgotten from always be forgotten when you are coding with Arduinos. So as you can see, the setup is mainly used for setting up things, which pin you want to use, and Wi-Fi initialization and Wi-Fi settings, if you want to use Wi-Fi on the Wemos D1 Mini, etc. And the second function, loop, is your main application, which is what we want to do with those pins. What we want to do if something happened with one of those pins. So we put it in here, and this code runs forever until you change the code again later. And this thing, the Arduino doesn't have a file system, which is I will explain in Micropython. Yeah, so this is the syntax for Arduino, which is based on C, heavily modified C, high-level C, and it has many objects related to the Arduino itself. Now, for the Micropython, well, actually, the MicroPython is actually Python 3, a pure Python 3 running on a single chip. Running on a single chip. It has a full Python 3 in it. So this is not a ground up Python or a higher level of Python, but it's a pure Python 3 language which has a few extra objects in it. Like in this example, pin object, Wi-Fi object, etc., which is correlated to the microcontroller. Now, as you can see, because this is running a pure Python 3, you can write the code just like a regular Python. Oh, by the way, the previous video I don't explain about, at the first part, I don't explain about the IDE for the MicroPython, because at that time, there are no great IDE that can do code for MicroPython very good, which is now I have used the UPyCraft IDE, which is very good from the FRobot. Remember, the FRobot has made this, yeah, which is an excellent IDE from the FRobot. And now, as you can see, there are no function. There are no main function. Sorry, there are no required function for Python, for MicroPython. Unlike the Arduino, there are no setup, no loop. You just call what the object and the library, which pin that you want to use. In this case, like this, the LED built-in output, you don't have to use it in the function. You just call it right there in the Python itself. But we need to import the machine library first, and then we can call the pin object in here. And then, if you want to loop something, you just do a basic syntax like while true, and then you can loop the LEDs on and on again, just like that. It's so simple. Now, I'm going to compare the upload time between these two microcontroller. I'm going to minimize this first. I'm going to put it in here. Okay. This one is Arduino. This one is MicroPython. Which one is going to blink first, as you can see? Oh, I forgot to tell you. This MicroPython, as I mentioned before, has a file system, which in Arduino, it doesn't have a file system. Which is, if you use Arduino, you can only upload one code and also including a few libraries, and then the code will run by itself, and it's only run that code forever. But in MicroPython, you have a few options. If you want to stop a single code, you just stop it, and then you can run another code like this one. I can add a few more code as long as the memory has still has so much more space in it. Okay, now I'm gonna try. Let's try to make the loop. The delay is same. It's 1 second. Now I'm gonna try to upload the code together and see which one is faster. Which one is faster to upload the code? As you can see, this one is Arduino. This one is MicroPython. Okay. In this case, I'm gonna let Arduino upload first, and then I'm gonna click this one first, and then I'm gonna click this one after Arduino, and see which one is running first. Okay. Okay, I'm gonna click upload this, and I'm gonna click this one. As you can see, the MicroPythons already run the blink code directly. Not even a single, I don't know, I think it's below 2 seconds or 3 seconds. Because it's already, it doesn't compile the code, it just run all the function that's already in the firmware, and then just call it like that. As in Arduino, as you can see, it's still compiling, because it's run the, I think it's run the ESP SDK inside of this, and then make the bin file, and then launch it, and then flash it again to the Wemos D1 Mini Board. So as you can see, it's already blinking in a while, but the Arduino still still compiling. I don't know for how long, because sometimes it's fast, sometimes it doesn't. I don't know what's causing the speed of the compiling and uploading. And also, sometimes we will get an error because the USB serial doesn't sync correctly, which is in this case, it syncs correctly. As you can see, it's uploading. Oh my god. This thing is uploading, and it's uploading, and now it's already running the blink code. So, I'm not gonna, you'll be the judge, okay? As I can tell you, just a comparison. Okay, there are things that Arduino is best can do, and there are things that Micropython best can do. There are things that Arduino cannot do, and there are also things that Micropython cannot do. Okay, so as you can see, on uploading code, Micropython is already faster. I don't know, sometimes I can upload faster using Arduino. Maybe it depends on the RAM or the processing power. I don't know. Okay, next is the Wi-Fi connectivity. So if you check here in the examples from the Arduino IDE, we have an example for a web server like this, Wi-Fi web server. And as you can see, this thing is calling your SSID and password every time you want to code. In Micropython, you can put your Wi-Fi credential directly every time you boot. So it doesn't matter what code you want to use, you can put it in the boot.py or main.py. So for example, I think I have a few. So like this, I just copy this and I just put it in the boot.py, and then I paste in here, and then every time the Micropython reboot itself, it will directly connect to my Wi-Fi credential regarding what kind of code that I want to use. Unlike the Arduinos, as you can see, every time you make a code, you have to call it first, and then you have to make a variable about the SSID and the password, and then you have to call it in the setup function, like this. Well, in Micropython, as you can see, I can run it every time I boot the microcontroller. Okay, I'm gonna erase this first. Now, I'm gonna try another thing, which is an interrupt or a timer function. Which one is it? This one. Okay, as you can see, I'm gonna strip this one for a file. Okay, as you can see, I have two LEDs connected to the breadboard. As you can see, this one is in the Micropython, this one is in the Arduinos, and we also have onboard LEDs, which is already blinking on each board. Now, what we are trying to do, what if we want to blink these two LEDs, but in a different timing? So, like, for example, if you want to blink this one for 1 second and this one for a half second or 0.1 second, you can't do that in the loop, because loop will always check the first code first, the top code first, and then it will execute the next one. So you have to do some kind of technique, which is timing or millis in the Arduino. In the Micropython, you call it a timer. So as you can see, this thing runs the same thing. This code execute the same thing on the microcontroller. Okay, I'm gonna, as before, I'm gonna erase this one first, delete the code. Okay. Sorry, I haven't stopped the blink file. Delete. I think it. Yes, please. I can delete the code and I can call it anytime I want. Delete OK. Okay, as you can see, the code is not in the board. Now, as you can see, this is I'm calling two LEDs, which is connected to the D1 and the D4, and I also connect the same thing to the Micropython board, but the naming in the Micropython board is a little bit weird because we cannot call D1 or D4. In a Micropython Wemos D1 Mini tutorial, they have already pinned out regarding the Micropython syntax for the Wemos D1 Mini. So if I want to call D4, I have to call pin 2. If I want to call pin D1, I have to call pin 5, which is a little bit weird, but it's okay. I don't mind. Okay, as you can see, the Arduino doesn't need any library to do this, but in Micropython, as you can see, I need machine library, and I need to call the pin and the timer object to do this. But as you can see, the code in the Arduino is it's quite long. I don't know how many lines in there compared to the Micropython. As you can see, it just only consists of few lines, which I have space for aesthetic. Okay, as you can see, I call the 2 pin, and I have 2 timers in here. One is 0.1 second, and the other one is 1 second. Same in here, I have D1 for 1 second, and D4 for 0.1 second. And now, as before, I'm gonna let the Arduino to upload first, and I'm gonna run the Micropython now. As you can see, it's already running. So fast. Yeah, using Micropython is so fast, you can directly run the code in Micropython without compiling the code first, because Arduino is a firmware that already have so many objects that you just call it. Okay, we're still waiting for the Arduino to run. It's supposed to be run the same thing. As you can see, the onboard LED is running 0.1 second blink, while the LED on the breadboard is running 1 second blink. Same with these things. Yeah, it's running the same code. And now I'm gonna make the code. In Micropython, you have to choose which code you want to run as a default. Well, and in this IDE, as you can see, you can do it by clicking. If you are already confident which one you want to run forever, you just click and choose the default run, and then you're done. And now, every time I press the reset button, in Micropython, sorry, it will run the default of the it's not running. I think I made a mistake here. It's not running the blink to LED. Okay, default run. Oh, sorry. Okay. Why is not running? And now it's running. Now that's a minor from Micropython. It's so buggy, but not as buggy as before. The Micropython community has done a great job updating the Micropython firmware each day, each week, maybe each hour. Same as with the Arduinos. This one is already run almost perfectly. The Micropython on the Wemos D1 Mini. Now, as you can see, Micropython and Arduino already run the same code. Now, if I press reset on the both, we will see which code run first. Okay, so I'm going to try to press reset together, and we will see which one is it, the Micropython or Arduino will run the 2 LED blinks code first. 1, 2, and 3. almost no different. Okay, I'm going to try it one more time. I think Arduino is run faster than Micropython when it comes from a reset state. Okay, I'm going to try it once again. 1, 2, 3. Oh, I think it's almost the same. Okay, one more time. 1, 2, 3. I think it's almost the same. I thought Arduino will run faster than Micropython from reset state. But as you can see, it runs almost the same. Okay, so that's it, another comparison of Arduino and Micropython. I humbly thank you so much for the people already watched my first part of the Micropython and Arduino videos. Micropython versus Arduino videos, because it has so many views. So I make this part 2, so it will give you a much more views about Arduino and Micropython, which is the most, these two frameworks are the most exciting framework in the macro world, in the embedded world. I use these two frameworks anytime, based on what I need. If I can use Micropython quickly, then I will use Micropython. But if there are no libraries for Micropython, then I will jump into Arduino, which is already has so many libraries on it. Which is, these two things are great. So thank you for watching these videos, and I will see you again next time. Bye bye.